Ciao friends, and welcome to a new Unplugged video from SQL BI. In this video, I want to show you quite a strange behavior that happens because of the optimization that the DAX engine performs over Boolean calculations. It's not a behavior that you will find easily because you're required to have a Boolean condition in a calculated columns that is compared with true. And in this specific scenario, the behavior, the values that are stored in the calculated table are quite unexpected. With that said, in order to obtain the good scenario, so to show you the effect of the optimization, what I need to do is first prepare the setup that triggers the optimization. To do that, we are going to write the code for a like-for-like comparison. We want to see the sales in the previous year for only the days where we do have sales in the current year. And this needs to happen at the store level. We will start writing the code because in Unplugged videos we always write the code together. And then we reach a point where we will need to optimize the code. To do that, we will create a calculated table, a lookup, and finally, we will be able to see the effect of the optimization that, of course, we are going to solve before the end. Let's get started. First, the scenario. In this report, we have sales amount and sales in the previous year sliced by both year, month, and then date. Sales previous year is a very simple calculation that uses calculated to move the filter context back 1 year by using same period last year. So it's showing the sales in the previous year. With that said, you can already see the behavior here because on the 1st and on the 2nd of June, everything is fine. We have sales both in the current year and in the previous year. But on the 3rd of June, we have sales in the previous year, but we do not have sales in the current year. Now, the requirement is to get rid of this value because we do not have sales in the current year. And this needs to happen at the store level. It's a like-for-like comparison. So right now we are looking at all the stores together. But if we look at an individual store, and we can also reduce a bit the number of rows. So let's focus only on June. So let me add a few filters here to make it easier to understand everything. We only focus on 2018. Then I also want to filter the month. I'm only interested in June. Okay, now it's a bit better. And besides, I also want to filter the store. So let me go to the store name. We add this as a filter too. Right now I'm looking at all the stores. But if we focus only on one store, you see that the scenario is different. Because for only one store, the number of days where we do have sales in the previous year but not in the current year is different. If we get rid of the filter on the store, focus on the 12th of June. 12th of June should not be visible for the store that I selected, that I don't remember. It's Contoso Store, Alaska. But if I select everything, the 12th of June looks like it should be considered because there are sales both in the current year and in the previous year. But with a single store, I should not consider the 12th of June. The selection needs to happen both at the store level and at the date level. So for each individual store, I need to check the dates in the current year and use the dates in the previous year only if there are sales in the current filter. Now, there are multiple ways of solving the same scenario. We could use a SUMX, iterate of a store, and then compute the comparison between the current year and the previous year, maybe using variables to store the sales in the current year and in the previous year. But all these solutions that require iterations are going to be utterly slow. Therefore, we want to follow a different approach. What we are going to do is find the dates in the current year or in the current selection, and then only the dates with sales, and then we move them back 1 year. These need to happen both at the store and date level. So we are going to create a table containing the store, the date, the dates in the current year, and we move the dates back 1 year, and we use this as a filter over the date table, over the sales table, in order to see the dates in the previous year for only the days where we do have sales in the current year. Because we need to create a measure that uses a temporary table, it's a good option that of starting to create the table first. That helps in understanding both the algorithm and to write the code checking the values, so that we can then use the code in the measure in an easier way. Let's do that together. What we want to create is a table that contains first the 3 dates in June 2018 for the Alaska store. So these 3 days, the 6, the 23, and the 30. Then we move the dates back 1 year, and we use that as a filter. Let's do that with DAX Studio. External tool, and then DAX Studio. And we start creating the temporary table. So we can use summarize. We summarize sales by data. That is going to return all the dates. That is not what we want. As I said, we focus only on June 2018. So we add a filter outside. And we want the date year to be 2018. And we also want the month, the date month number equals 6. Now, if I run this code, you see that I have several dates in 2018. Not all the dates. The 3rd of June, for example, is missing. But I still need to have a filter over the store, because I want to replicate the same scenario that I have here. Now, the store that I selected here is Contoso Store Alaska. I don't know the code of Contoso Store Alaska, so let me go to the store table and zoom in a bit. And we search for Contoso Store Alaska. Here it is. It has the code 430. So we can go back and add a filter for only the store key equals 430. And if I run the query now, I have the data 6, 23, and 30. That happens to be the same dates that we have here. 6, 23, and 30. Dates with sales. In our table, we do not want only the date, we also want the store. So we can add the store key here. Store key. We run the query, and now I have a table that contains the store and the data. Next step is to move these dates back 1 year. So I can create a new column using add columns. And we create the previous year data. That we can use date. We take the year of date, and we subtract 1. Whereas the month is the same month as the date, and the day is the same date as the date. Now I messed up everything, because actually that should have been year of date, month, and parentheses closed this way. Let's reduce that a bit. So the previous year date is the data in the previous year for the current month and the current date. Now, if I run it, I now have the store key, the date, and the previous year date. I'm not interested in the date, I only want the previous year date that I will use as a filter over the date table. So we can restrict that a bit using select columns. And out of this table with 3 columns, we retrieve only 2, which are the store key, that is store key, And then we want the date key, which is not the date key, but it is actually the previous year date. Let's format it. And now this should return only two columns, store key and date key, where for the date I will have dates in 2017. Indeed, I have the 3 dates of 2018 moved back 1 year. Now we can we can just copy this part, because this is the table that we are going to use. We store it in a variable, in a measure, and then we use it as a filter. So we can go back to Power BI Desktop, and we are ready to create our measure. Let's call it sales previous year, like for like. We have a variable that is dates to consider, and we place the code of the query that we created. So now dates to consider will contain the two columns, date and store. And then in the result, we calculate result equal calculate sales amount, and we use dates to consider as a filter. Finally, return result. That should be it. Maybe reduce the font a bit. Okay. We format it as a decimal number, and then we give that a try. Sales previous year, like for like. It's looks like it's working. Okay. But I think it's working only by chance. Let me see what happens if I make a selection over multiple stores, for example. Why does it show the sales amount here? Oh, let me go back to Contoso Store, Alaska. Now, actually, it's not working at all, because sales in the previous year is returning the sales in the current year, not the sales in the previous year. And that happens constantly. You see, it should return blank because we have sales in the current year but not in the previous year. Instead, it's returning the value of the current year. So what's happening here? We create the variable containing the store and the date. We use it as a filter, but of course, the previous year date is a column that I'm computing here with an expression. I'm not telling the engine that previous year date that I rename as a date key is actually a date key. I wanted to use it as a filter over date. I need 3 tasks here. Dates to consider need to be considered as a store key, that is the first column. And the second column is a date. Now with 3 tasks, the previous year date, that is a calculated column, will be used as a filter. And if I did it correctly, now it shows a blank everywhere. Let's go back to our example. That was Contoso Store, Alaska. And it seems like it's working. You see that it's retrieving the sales in the previous year if there are sales in the current year. It's not returning these 2 values, and it's not returning anything here because there is nothing to show. It is returning a value here because we have sales both in the current year and in the previous year. And of course, because we're applying the filter at the store level, if I get rid of the filter from the store entirely, the calculation is now computing store by store the set of dates that happen to be both in the current year and in the previous year, which is cool. But we do have a small issue, that is performance. Let's look at this code. Maybe instead of looking at it here, we can look at it in DAX Studio. That's because we can make it a bit larger. Okay. Let's do a quick analysis of the complexity of this code. This select columns retrieves a table that contains the store key and the date key. So for a year of data, there will be 365 days in date key, and store contains one row per each store. Meaning that if you have 1,000 stores and 365 days, you end up having 365,000 rows in this table, which is quite large. And that is if you have 1,000 stores. If you have 1,000,000 stores, this is going to be a nightmare, because this table will become really large. Therefore, the filter that will then later be used by Calculate is going to be large, and on complex tables, this is going to slow down. This does not depend on the size of sales. It mainly depends on the cross-join of store key and date key. So the more stores you have, the larger the period you are considering, and the slower this formula is going to become. What we can do is try to optimize it in some way. The best way to optimize this code, the best way that I have in mind right now, is to move the entire logic in a calculated column. We can create a calculated column in sales that indicates whether a date needs to be used to be compared with the same date in the next year. So we are going to store a Boolean flag in sales that tells us whether that individual sales needs to be accumulated when we look at 2018. So it will be a Boolean indicating whether we want to use this date for the next year. Now, being a calculated column, we can just duplicate the code that we have here by checking row by row if there are sales in the next year. But the code is going to be quite complex. The measure we are using, you see, it uses summarize, but it also uses date. Data, so the calculation of a data, that requires formula engine. So if we store this code in a calculated column, it's going to be utterly slow. Another option that we can consider is to create a snapshot table that contains the store, the date, and the Boolean flag. And then this is a calculated table. We compute it only once, so formula engine will be involved only once in the entire calculation. And then we use lookup value to retrieve for the individual store the flag from the snapshot. That is going to save us a lot of time, because the calculated column will be faster to compute. So even on larger table, it shouldn't take too much time. Let's do that. What we are going to do is take this calculation, the entire select columns, and build a calculated table out of it. So let me take this entire select column. Then we go here and we create a new calculated column, new calculated table. Modeling new table, dates to consider. And that contains a summarized sales by store key and date, previous year date, and then store key and date key. That should be it. We create the table. Let's see whether the table is there. And it is. We have now a table that contains the store and the date, only for the dates that we want to consider. Actually, we will use lookup value to retrieve a value from here, so we can also add a Boolean column, use date, which is always true. So we will search for use date for the pair of store key and date key, and we retrieve either true or blank. And then what we can do is create a calculated column in sales that performs the lookup. So we create a new column. Use date that does a lookup value. We want to retrieve from dates to consider. Use date, where dates to consider date key is the same as a sales date key, order date. And the dates to consider store key is identical to sales store key. Now we do have the calculated column that contains, let me zoom in a bit, true when the individual data, so this date in 2018 for this store needs to be used for the next year, that is 2019. Now, we reached finally the point where we are going to fix the problem, because you see that the column exists. It contains either true or blank. Why that? Because we are doing a lookup value. So we are using lookup value and we are retrieving the use date when the date key is order date and the store key is the store key. Either we find this row or we don't. If we find it, we know we're going to use the data. If we don't, that means we are going to ignore the data. But if we do not find the data, then lookup value returns a blank. And use date stores either true when there is a match and blank if not. Now, personally, being a geek, I do not like a Boolean column to have true or blank. To me, a Boolean needs to be either true or false. So I want to have only true or false here. And I can do that if instead of just retrieving lookup value, I use a comparison operator. I check if lookup value returns true. If lookup value returns true, then the value will be true. If lookup value returns anything except true, then the result will be false. So I hit enter. I look at the content. And you see that I still have a lot of blanks. I have my true values and I have a lot of blanks. I can also check it here, but I only have either blank or true. That is kind of weird. How is it possible that using a comparison operator, I still obtain blanks? This has to do with an optimization of the DAX engine. Think about that. If you have a Boolean expression and you compare it with the constant value true, the final result will be either true or false. If the expression is true, then the result will be true. If the Boolean expression is blank or false, then you want false as a result. When you use this expression in any condition, false and blank, they are treated the same. Therefore, the result of the comparison is actually the same result of the expression. And the DAX optimizer simplifies the code, removing the comparison operator, because at the end, the result of the comparison operator is the same result as the expression itself. Therefore, it simplifies the code to make it faster. This happens only in the very special case where you have a comparison with true, because it's the only scenario where the result of lookup value and the result of the entire expression is actually the same. If we compare it with false, then the optimization does not kick in, because the result of the expression is not the same as the result of the comparison. If I use false, now you see that inside use date, I have true or false, exactly what I want. But now I have the opposite value. So I could add a not before everything, like using different than false. And now I obtain my result, the correct result, that is false or true. Or I can use another technique that uses coalesce. And we say, if the result is the same result as lookup value, so if lookup value returns true, then we use true. If it returns blank, then we use false as the default value. Again, this is going to work. And if we look at the details here, you see that we have true or false. It is also interesting to double check this behavior, because we know about the optimization, but maybe we want to go further and understand exactly what is happening. So what we could do is check the query plan of the calculated column in using DAX Studio. The problem is it's really complex to check the execution plan of a calculated column, because you should monitor the processing time of your data model. That is the only way you can actually understand exactly what happens during the evaluation of a calculated column. But what we can do is try to guess it. We can use add columns to add the same code of the calculated column to the sales table, and that will result in a query that we can use to verify whether the comparison operator is always used or not. Let's try to do that. I want to take this code and use it in DAX Studio in a new query. So we use evaluate sales, but we use add columns to simulate a new calculated column. Let's call it test. And then we use our code. Let me get rid of this coalesce. That should be it. This is evaluating the entire sales table sales, which in my case is tiny, so I can easily retrieve it. If you have billions of rows, don't do that, because it's going to take forever to retrieve the value. And I use the code of the calculated column with equal false. Then we activate query plan server timings. Actually, we do not need the server timings, but it's not bad to have it. And then we run it. Let's take a look at the query plan. Now you see that in the physical query plan we have add columns, and then we have this equal to, that depends on order date and store key, and on a Boolean condition. This is the equal to operator that checks for equal to false. It is actually easier if we look at it in the logical query plan. You see that the logical query plan is much smaller, and we have add columns, the scan of vertipack, and then equal to that checks for equality with the constant value false. What happens if we check for true? If we check it for true, we run it, and then we take a look at the query plan. The logical query plan is easier. You look at the logical query plan, we have add columns, scan, calculate. The equal operator disappeared as the constant value disappeared. And the same happens here in the physical query plan. We no longer have the equal to operator, meaning that in the only scenario where you do a comparison with true, the engine gets rid of this part in order to simplify the code. This code generates the same query plan and the same scenario that we have seen before. Now, before leaving the topic, we did all this work in order to simplify the code of our like for like. So let's check that it actually works. We can go here. We now have the use date column that is either true or false as we like. We have sales previous year like for like. We can create a new measure. Let's call it sales previous year like-for-like optimized. But now I can leverage the calculated column. So I can just compute the sales in the previous year, where use date, sales use date equals true. Inside keep filters, just to be on the safe side. That is much simpler than the previous code. Let's check it as a decimal number. And that should be it. If I place it here, it shows the same value as sales previous year like-for-like, but it's gonna be much faster because look, this is the code of sales previous year like-for-like, and this is the code of the optimized version. It only uses one filter on a Boolean column, so it's gonna be incredibly fast if compared with this version. Of course, at the price of having a column in the sales table that indicates whether we want to use the value or not. So, as you have seen, we have spent quite a lot of time writing the DAX code to build the scenario. This is actually the code that I was working with the customer when I discovered this strange behavior. And then some time in order to investigate on the problem and understand about this weird optimization. It's an optimization that doesn't happen frequently, because in most scenarios you compute a Boolean value to perform conditional logic, and in that case blank and false, they are the same value. They are treated the same and they result in exactly the same calculation. But only in the very special case where you store the result of the Boolean value in a calculated column, because Boolean calculated column can contain true, false or blank, you will have a difference. You will have blank instead of false if the lookup value failed in finding the right number. As it always happens with DAX, whenever you see something strange, you have two options. Either you say, well, it's strange, I don't understand it, but I'm happy, or you dig deeper. And if you really are interested in learning about DAX and understanding all the details, it is important to spend time understanding all these behaviors, because who knows, maybe one day this knowledge might be extremely useful in optimizing some code or in understanding better strange behaviors of the DAX engine. Enjoy DAX!